So good morning, everybody. Just going to get out of my slides for a moment. We're going to try a new interactivity bit today called Pear Deck, and it'll allow you all to interact and answer questions with, as we go along. There'll be like survey questions, you'll be able to move stuff around on the screen. So when this loads, there'll be a website and a little code that you need. So if you've got a second device, a phone will work, or a laptop or a tablet, or just on your computer screen, you can just go and open up a new tab. The website you'll go to will be joinpd.com. It'll pop up in just a minute. And then you'll type in the code that appears on the screen. Here we go. So there's the website you need to go to. So on a different device or on a different tab in your screen, go to joinpd.com, and then you're going to type in this code. I'll read out this phrase a few times because it'll appear on your screen as you type it. So it's acidic incentives wish troubling lemons. So AIWTL. You just type that code in. If you don't have a device that's going to allow you, you'll still be able to interact and answer. You can answer the questions in the chat to us if you like. Certainly it'll work on all sort of handheld devices, so phones or tablets. So if you're on a computer, you can open up a new tab, like next to the one that you're on the Zoom call with. Okay, so a bit of a reminder, make sure everyone's in the right place. You'll see the code in this top right corner if people need it later. So we're going to do today, this is our third lesson, and we're going to focus on ratios and rates. The whole chapter is ratios, rates, and time, but I'm not going to do the time bit today because I didn't want to have to rush too much, and I really wanted to be able to take my time on those, two components of ratios and rates. So that's what we're doing today. So if you've accidentally come into the wrong class or the wrong year level, that's okay. We're going to be doing year 8 ratios and rates today. That's our focus. So a little bit extra about me. So each week I just give you a little bit more information because I figure if we were in a classroom together, we'd be getting to know each other a little bit. So my name is Miss G, Erin, and Renelle, who's also on the call. Miss J, she's there as well. She's doing some stuff in the background for us today. And so this week I thought I'd just quickly and briefly talk about what's my favourite and least favourite maths topic. Because, not everyone needs to like everything. And even though I'm a maths teacher and I love what I do and I love really most mathematics, there are some things that I'm not so crazy about. So for me, my favourite maths topics are things that are to do with describing patterns and relationships. I really like that, especially in nature. So that's a picture of a passion fruit flower. It's the first time my passion fruit's ever flowered, so I was very excited. But look at the intricacy in there, and there's so much mathematics. Natural numbers and fantastic things about in nature and patterns and things like that. So that's certainly one of my favourite maths topics. My least favourite maths topic, probably geometry. Not a fan of geometry. I like shapes and I can deal with them and they've got rules and stuff like that, but doing stuff with geometry, yeah, not my favourite. If I had to pick, I'd probably choose something else if I could. What about you, Miss J?
Well, I thought really hard about my answers this morning, and you kind of stole my first one. I also really like patterns in nature, like Fibonacci sequence, and thinking about how that shows up in fruits and plants. But I'll think of another one. I actually, this isn't really a topic, but I really enjoy talking about food in my classroom. And it doesn't matter what topic we're on, my context problems always end up being about food. For my least favorite, I'm going to take a negative and turn it into a positive. I really don't like statistics. It's just never fun for kids to do statistics. And I really didn't enjoy teaching box plots. Which in the US we call those box and whiskers, but we ended up making them really fun by turning a box plot into a little cat face. And so that didn't really make math any more fun, but it sure did make the graphics more fun.
That's fantastic. All right, so this is going to be our first test for our interactive. So on our next screen here, we're on your Pear Deck slide. You'll have a new screen pop up. and you'll have a little icon. There'll be a little tick and a little cross in that top right corner. I want you to drag the little tick to your favorite sort of area in maths, and then the little cross to your least favorite area in maths. You just drag those little things on your screen over to your least favorite or favorite. And this is just giving us the warm up into the interactivity that is Paired X, so that we can make sure we're all in. We just need to, oh yeah, we've got heaps of responses in. That's fantastic. I'll just show the responses. Now here are the little ticks and crosses moving around. That's fantastic. So see if you can line them in, move them into where your least favorite and favorite is. I know maybe your favorite's not there, or maybe you like it all, but just for the exercise today, just sort of find it and move it in. See if you can line them up into the little tape. Might be hard if you're on a small device, but just another 3 seconds and I'm going to lock the screen. So get it into your spot where you want to put it. In 3, 2, 1. Okay. Oh, there we are. Lock the screens. Fantastic. Look at that. So a lot of people like the algebra type component. Yeah, a lot of people with me, geometry, not so great. A few people with Miss J there about the data not being so fun. That's good. It's good indication. So as we go through the course over the term, then we're going to be doing, our next topic is algebra, so that's great. Looks like people will be excited about having a go at that. And we will touch on a little bit of measurement before the end of the term, so that's sort of what's coming up. Fantastic. Okay. So general housekeeping, I've been going over this. I know we've got a lot of repeat people, so I won't go over it too much. Hit the key points here. It will be recorded, so you'll be able to watch the recording. So if you feel like you want to go back over the example or do some of the examples I do again, that's where you can go to get the recording. You'll be able to pause and stop and take your time. The slides that I use will also be there, so you'll be able to go back through and click through the slides. Just make sure you know where the chat is, and I know most people have been dropping in a little hello to the chat, so that's great. There's also a Q&A section in Zoom. So if you have specific questions that you'd like myself or Miss J to answer through the lesson or at the end of the lesson, throw it in there and we'll try and answer as many as we can. Fantastic. Okay, so where are we in our learning? Like I said, this week is on chapter 3. It's a review session. The way we set this up was our first 3 weeks were to try and bring everyone, sort of catch everyone up so that we can start our term 2 work, which is where we're going to start with chapter 4 and algebra, all at the same place. So we've been working on real numbers, and then we did some stuff on percentages, and this week is ratios and rates. Next week we're going to focus, and it'll be more of a slower pace because it won't be an entire chapter. We're just going to do a couple of sections from the chapter on algebra next week. And in fact, algebra is split up over 2 weeks. So I'll remind you again that if you do want some more detailed videos about each of these topics from the chapter, you can go to WooTube. We've got Eddie Woo videos in there for each of the sections from 301 through to 305. Now, last week, for those of you who are here, I ended with talking about this 9 by 10 array and going away and colouring it in. I did one, and we're going to talk about this example. If you've made one as well, you'll be able to use your example as we move into some of our ratio stuff today. So the one I made looked a bit like that. I made a big letter E. I used 4 colours, red, green, yellow, and blue. And the activity was to count up how many squares, or you coloured in for each of those colours, and then work out the different representations for fractions, decimals, and percentages. So if we just look at my red example, there were 38 squares. The fraction is 38 of the 90 whole squares, and that could be simplified to 19/45. And then I converted that to decimals and percentages. Decimals was, to convert to decimals, we just did the division, so 19 divided by 45, and then from the decimals we can get the percentages. So that's basically a recap of our first 2 weeks, where we talked about rational number, fractions and decimals, and then last week we talked about percentages. So if you've got your coloured grid there and you coloured it in, then you could use your grid for the next bit when we talk about ratios, or mine will be on the screen. So if you don't have one, you'll be able to use my letter E. So we're going to start with ratios. What is a ratio? So it's a relationship between two quantities. So it can be any two things, and we're just talking about how that relationship exists. We can talk about part-whole relationships, so a part of something to the whole of something. We can talk about part-part relationships, and I'm going to go into both of those in a bit more detail soon. Intuitively, we do use ratios all the time. When you're shopping and you're looking for the best deal, when you're cooking and you want to change the recipe to make more or make less, if you're just observing things in nature, or even when I was walking around outside yesterday, I noticed that most of the flowers in my vegetable garden were yellow, and I thought that was quite interesting compared to purple, and there was definitely nearly twice as many yellows as there were purple flowers. So just generally, then it's a natural thing to do, to think about comparing things together. We usually use a notation that uses that little colon symbol, the two dots, one on top of the other, when we're talking about ratios, and that's how we represent a ratio in mathematics. So there's two examples here on the screen. 2 is to 3 is how we would say this, 2:3. So 2 parts to 3. The second one's got a decimals, and that's okay. Ratios can have any type of number in it. They can have fractions, decimals, percentages, whole numbers. Can even have some of our irrational numbers if you wanted to. And this one is 0.4 is to 1. So, you know, like we could talk about making a big jug of cordial, and, you know, you have 0.4 parts to 1 cup of water, something like that. So you get the ratio right. It's really important when we're talking about ratios and rates as well, that we'll do later, that because generally we use these and they're all in context. There's a reason that there are objects that we're comparing. So if you want to be able to interpret them correctly, you want to be able to talk about them and make assumptions or statements, answer questions, you really need to know the context. And part of that context determines the order. So 2 is to 3 as a ratio is very different to the ratio 3 is to 2. The order matters, the context matters. So try and keep that in mind. Okay, so here's my little grid again. We're going to talk about part-whole ratios first. So that's when we look at a part of something and we compare it to the whole, or what, you know, how much of the whole was it? So here is how I'm writing these ratios. This first line in the table, you'll see red is to whole. So that's the part, is the red, to the whole component. I know that there are 38 red squares. We worked that out in the previous week. That means I write the part-whole relationship as 38 is to 90 with these little dot dots. So just have a look at one of these other ones here, and just, you don't need to do more than just think in your head, how would I write one of these relationships as a ratio? So how might you write the green is to whole ratio, or the blue? Just sort of have a bit of a feel about that before I reveal the answers there. Yeah, so hopefully you get something a bit like that. Some people dropped us into the chat. That was great. So Tanvir, I can see, yep. So you can do that as well. You can throw your answers into the chat if you like. You can see here that these part-whole relationships, it's just about recording and writing down those values. Now, there's a tricky thing here. They are exactly the same as the fractions that we had. So indeed, most fractions are actually part-whole ratios. So, you know, the fraction that is red was 38 of the 90, and that is exactly the same as our ratio of red to the whole, 38 to 90. The other neat thing is that because we can simplify fractions, we can also simplify ratios. So when I simplify the ratio, 38 is to 90, I get exactly the same answer as if I would have simplified the fraction, 19 is to 45. So I just wanted to pause for a moment and show you how you might do these simplifications using a calculator. There are many by hand methods. You can find the common factors and cancel them out, and you would have done this through year 6 and year 7. But now we want to be able to get to using ratios. We want to be able to simplify these things quickly. So I've got a calculator here that I've just got from GeoGebra. It's free, it's just on the web. And what I can do is type in my fraction, 3890, and then I can just simplify it. So I can see there that the simplified fraction is 19 over 45. So you don't need to get caught up in the arithmetic so much. What's really important is that I want you to keep up with us when we're talking about the ratios and the simplification there. Okay, so part-whole relationship is very much like a fraction. It's the part, in this case it was red, to the whole. So we had 38 over 90 was the fraction, and 38 is to 90 is the whole. So that's our part-whole ratio. Excuse me. The next one is our part-part ratio. Okay, so this is where we compare two of the things that are in this together. So this is where we're going to compare two different colours rather than just saying how much red is there. So there's lots of different things that we can, with different types of parts that we could compare. I've just put a few on the screen here. Let's compare red to green, or blue to yellow, or blue to green, or yellow to red. Just want you to pick one of these parts and think about, right, how might we write this as a ratio? So the first step is, you just need to know how many of each part there was. I'll just do the red to green one first. So there were 38 reds and there were 12 greens. So that's the part. Red to green, 38 to 12. The order's really important because there were definitely more reds than greens. So just want you to pick one of the others and just write down the part to part ratio. You can just do it on your piece of paper in front of you, or you could throw it in the chat if you like. You don't have to even simplify it straight away. Just write down the part to part relationship. Yeah, thanks, Luke. It's really good. You need to write down, make sure you write down what is the relationship. The order matters, that's right. Okay, so here we are. Hopefully you've got some of these sorts of answers. The blue to yellow, so there were 24 to 16. There's more blue than there is yellow. The blue to green, 24 to 12, or the yellow to red, 16 to 38. Yeah, well done, Jodie. Now we can simplify those just like you would a fraction. Just need to find common factors and simplify them out. Because it functions in a very similar way. What you do to one side, you do to the other. We could double these ratios, we could halve them. We can use our unitary method like what we did last week with percentages. We'll do an example of that a bit later as well. But to simplify them, you want to find common factors that are in both and bring it out. So to do 38 to 12, if you wanted to do that one manually, it would be something like this. I'll just see if I can get my little pen here to work. Okay, so 38 to 12, you want to find common factors. So 38 to 12. What's common? What's a common factor in both 38 and 12? So I can see that they're both even, so I could start with that. I could divide them both by 2. Yeah, fantastic. There's a couple of people who have thrown that in the chat. So if I divided both of these by 2, I would see that this would be 19 and this side would be 6. So that would be our simplified. There's no more common factors between 19 and 6, so that's where we would stop. And let's just do one more. Let's do this one, 24 to 12. So we want common factors between 24 and 12. Well, in fact, I can see 12 is a common factor in both. Yeah, fantastic. Thanks, Josephine. So if I divide both sides by 12, then I'm going to get the simplified ratio of 2 to 1. Fantastic. And what that means is there is twice as many blues as there are green. So if we're going to put that into context, twice as many blues as there are green. With this one up here, there is a little bit more than 3 times as many red as there are green. So it's all about being able to describe the relationship. Yep, some people have thrown in some of the other answers in there. That's fantastic. I'm just going to clear out my drawings. I've got the answers on the next slide, so you can check what you did there. So you want those sorts of answers when we simplify them down. Fantastic, thank you, Ron. Blue to yellow, yeah. You can go one more step there, Ron, to simplify it again. But 6 to 4 is also equivalent. Okay, fantastic. So they're the two main types we've talked about. Part, whole, which is where you take one part and describe its relationship to the whole of the object, or part, where we're describing the comparison between two of the objects within the whole system. Okay, so that's what we've been doing, describing relationships between quantities. That's really the key point there. Okay, we've got another interactive. So you jump over to your Join PD or your Pear Deck site. Okay, so which of the following is not a ratio? So don't answer that question in the chat. I want you to, unless you didn't join the Pear PD, what you do is at the bottom of your screen, there's a green button that says answer question. You'll click on that and then the 4 options will pop up and you just pick the one that you want to answer with. So the question is, which is not a ratio? Remembering that when we're talking about ratios, we want to compare or discuss the relationship between two quantities. So that's the key thing about ratios. We want to be able to describe the relationship. Just check, we've got about 11 responses in. Just wait a bit longer before I put the answers up on the screen. I don't want to influence your thoughts first. So which one is not a ratio? Just waiting on a few more responses. What I might do is I'll read them out very slowly in case you have troubles reading on the screen. The first one is, there was one horse for every jockey at the club. The second one is, today was raining and it rained yesterday too. It should be today is raining. Bad grammar. The third one there is, for every 2 cups of flour, use 1 tablespoon of butter. And here are my chickens. And the last one is, I had 4 chickens from my flock of 42 jump the fence into my vegetable garden. How are we going? Oh, we're great. We're getting a lot of responses in. Just going to bring them up on the screen. So here's our responses so far. I haven't locked the responses yet, so you're still able to change your answer if you want. So I'm going to talk through them a little bit as we go. Okay. There was 1 horse for every jockey at the club. Yeah, we could actually write that as a ratio. It's 1 to 1. For every horse, there is 1 jockey. So that's correct. That is a ratio. I'm going to go to C now. For every 2 cups of flour, use 1 tablespoon of butter. So that is a ratio because we have the ratio of flour to butter is 2 to 1. So that is actually a ratio. This one here, 4 chickens of my flock of 42 jump the fence into my vegetable garden. And that's actually a part-whole relationship. That's still a ratio, 4 to 42. 4 out of the total 42 jumped the fence. So these are the naughty chickens and these are all the chickens, if you wanted to talk about what are the 2 quantities. So the one that is, and most people have the correct answer here, today was raining and it rained yesterday too, not a ratio. We're not comparing 2 quantities or amounts. It's just a statement about the weather, really. Okay, fantastic. Well done, everybody. I'm just going to lock that off. Okay, so now we're going to talk about equivalent ratios, and we're going to focus the next few questions on this one scenario. I've got a great pizza oven, a wood-fired pizza oven out in my backyard, and we make pizzas. And one of the pizza dough recipes we use is 2 ingredients, super simple, flour and Greek yogurt. Nice and simple, very quick. So the 2 ingredient pizza dough has 3 cups of flour and 2 cups of Greek yogurt. So you mix those together and that'll make us 2 pizzas. So we could write that as a ratio, remembering that the order matters and the context matters. So we can write that as a ratio, 3 is to 2. Okay, so that is our flour to yogurt ratio, 3 is to 2. Okay, so your next task, I want you to think about this a little bit. Don't need to rush. I'll give you some think time. I want you to write that same ratio, but for a different amount of pizzas. So I want you to think about, well, if I've told you this makes 2 pizzas, think about making 4 pizzas or 1 pizza or 20 pizzas. You get to choose how many pizzas you're going to make. And then I want the ratio from you of flour to yogurt. Okay, what is the ratio of flour to yogurt for a different amount of pizzas? So I just want you to, on those paired X slides, there'll be a little submit your answer at the bottom of the screen, green button. You click on that and then you can write the ratio. So you can write whatever numbers it is that you want to write in there for your ratios, whatever your answers are. There, we've got some answers coming in. That's fantastic. So I'm going to put those answers on the screen. And then what would be great is if you could try and come up with answers that are not on the screen. Come up with different answers if you can. Let's try and fill this up with as many different answers as we can. Yeah, that's great. We can see some answers coming in. So remember, our original one was 3 to 2. So this is the original ratio. We want something that's the same as that. Something that's the same as 3 to 2. So certainly there are some 6 to 4s there. Absolutely correct. If I make twice the amount, so if I make 4 pizzas, then I'll have twice the ingredients. I would need 6 flours and 4 yogurts. So 6 to 4, great answer. Two pizzas, 6 to 4. That would actually be 2 lots of our ingredient, but that's fine. 6 to 4 is correct. 3 pizzas, nice thinking there. So if I wanted to make 3 lots of the recipe, then I would have 3 3s is 9. That's fantastic. And 2 3s is 6. So well done. That's a good one. 3 pizzas, 9 to 6. Fantastic. Any more? Yeah, that's a tricky one. How many pizzas would that be for, whoever wrote that one? 40 pizzas, nice work. See, we can see we're getting some proportional thinking here. From 4 pizzas, which was 6 to 4, to 40 pizzas is 10 times the amount. So now it's 60 to 40, so that's perfect. And for 1 pizza, we would divide the recipe by 2, and this one would be here perfect, 1.5 to 1. Yeah, well done, everybody. That was good. Okay. Just going to give you another 3 seconds. Finish off your last answer. 3, 2, 1. And then I'll just lock that off. Okay, well done, everyone. That was great. So we've got a real good understanding now about how to proportionally adjust this recipe as you like. And I said that was actually one of the most common places we'll use ratios is when we're cooking. Okay, same context, same pizza dough recipe, 3 is to 2. I'm going to give you a multiple choice question on this next question. I'm going to give you multiple choice question about which one is not an equivalent ratio. Now, we've just talked a few. We had heaps on the screen. So basically, of the 4 options you've got there, which one is not equivalent to 3 is to 2? Which one is not equivalent? So just have a look at the options that are there. There'll be a little green answer button. You can click on that. Got about half the responses in. I'll wait a bit longer because I don't want people to get too swayed by what everyone else is thinking. So you want to make sure that we're adhering to our key points from this lesson is that the order matters, the context is important, and that we want to proportionally change up or down these values the same on both sides. I can't just double the flour and not double the yogurt. It'll be very dry. I certainly couldn't double the yogurt and not double the flour. It would be very wet. So you want to make sure you're proportionally changing both at the same time. Yeah, that's great. We've got about 2/3 of the responses in now. So let's put up the responses and we'll talk about them. So we were looking for a relationship that is comparable to 3 is to 2. Remember, that's what we're looking for here. So 3 is to 2 was the original one. So 6 is to 4. Definitely is, because I can times both sides by 2. If I times 3 by 2, I get 6. And if I times 2 by 2, I get 4. So that one is definitely proportional. The 9:6 is proportional as well. We had that on the previous slide, because I can times the 3 by 3, that gets 9. And if I times the yogurt part by 3, 2 times 3, I get 6. So that one is as well. So we certainly know that the A is and D is. Fantastic. 30 to 20, no one's chosen that, and that's because it is correct, because it's just 10 lots of the recipe. So I want 10 lots of the recipe would give me 30 is to 20. I times both sides by 10. So fantastic. So yeah, we're all on the same page here. We've got 20 to 30 is not comparable. And why is that? Well, firstly, we can see in this recipe, we've got less flour than yogurt. So it's going to be a bit soggy. So it's basically, we've got the order wrong, and the order really matters. So yeah, that is the incorrect answer. So that's fantastic. Oh, got to clear my drawings. There we go. Okay. Now, what if I want to make as much dough as I can, but I only have 5 cups of the yogurt? How much flour would I need for that? So I want to make as much as I can, but I only have 5 cups of yogurt. So we're going to work this one out on the screen. So this is how we'd attack a problem that looks a bit like this. So we know that the original ratio was 3:2. The goal is to use our 5 cups of yogurt. Well, this is flour, and this one is the yogurt. So the goal is I want to use 5 cups of yogurt. That's what I want. And somehow I need to get from 2 to 5. And this is pretty much exactly the same process that we used last week for unitary method for percentages. The easiest way to get from one place to another is via the unit, or via the number 1. Okay. If I know how much flour I need for 1 cup of yogurt, I can work out how much flour I need for any number of cups of yogurt. That's the easiest way. There are a couple of ways to do it, but we're going to just look at this unitary method for now. So if I want to go from my original recipe, which uses 3 cups of flour and 2 cups of yogurt, to just using 1 cup of yogurt, how have I done that? I've kind of halved the recipe, haven't I? So I'm going to divide each side by 2. Just like fractions, we need to do the same on both sides. Keep the proportion the same. So when I divide 2 by 2, I get 1. And when I divide the 3 by 2, I get 1.5. Okay, so I would need 1.5 cups of flour if I was only going to use 1 cup of yogurt. Now the next stage is to then proportion up. So what we've done now is got to the unit, which is the 1. And we want to proportion that up now. How do I get from the 1 to the 5? Well, that's just 5 lots of this recipe, isn't it? So I'm going to need 5 lots of that 1.5. So I need 5 of the 1.5 cups of flour. So that's going to be, okay, some people have thrown that in the chat, which is fantastic. So you're absolutely right if you said 7.5. We need 7.5 cups of flour for 5 cups of yogurt. So you'll notice, like I've said, same method that we used for converting for working with the unitary method of percentages. So it's the same process, just the symbols are a bit different. Instead of percentage signs, we're using ratio symbols, but the key points are the context matters, the order matters, and we need to keep the proportion the same, whether we're making it bigger or whether we're making it smaller. Fantastic, good work everybody. Just clear all that off. Okay, so that's the end of what we were thinking about doing for ratios. I think we're just a little bit over halfway through, so let's just quickly see. You can just drag your dot, there's a little blue dot. Feeling pretty good about ratios, put it over towards the green dot. You're a bit lost on ratios, you think you're going to need more help, throw it over on the red dot. So just start dragging your dots over. How are you feeling? Some people are great, a lot of people in the middle, which is fine. And there's always a few people who are sort of starting out. And it would be a bit tricky, I think, if you've turned up to this as the first one and you sort of haven't already studied it with your class or with your teacher. So that's absolutely okay. Fantastic. That's a really good indication for me. Okay, get your dots in. You've got 3 seconds. 3, 2, and 1. Well done. Okay, so I've got one quick more question. It's about bags of flour. It's another common context. Where is it gone? There it is. Another common context with ratios is best buys. What's the best buy? You'll see in the supermarkets, they always say, hey, if you buy 3 tins of cat food, it will only be $2. If you buy 5 packs of chips, it's only going to be $6.50. Like, you need to be able to know, is that a better deal than buying 1? Or is that a better deal than this other shop's selling them 3 for something? So just a very quick, this is another dragged icon. You're just going to drag your little dollar sign, which is the better deal. This is all about understanding your ideas for ratios. 3 bags for $5 or 2 bags for $3. Which is the better one? Which is the better deal? Assuming all the bags of flour are exactly the same size. Which one is the better deal? 3 bags for $5 or 2 bags for $3? So most people are thinking about their answers there. There's some dollar signs moving around the screen. That's fantastic. So I'm just going to do a little bit of work in the middle here whilst you're thinking about that question. So 3 bags for $5. Well, how much is this one per bag? How can I change this ratio on this side of $3 to $5 to a single ratio? 1 bag for how much? Well, I'd have to divide that by 3. So what is 5 divided by 3? So we could do that on our little calculator here. 5 divided by 3 is $1.67. So this is about 1 bag for $1.67. That's on this side. 1 bag for $1.67. Okay, what about this other side? 2 bags for $3. So this is starting out as a ratio of 2:3. Get you to lock in your answers in 3 seconds. 3, 2, 1. Has everyone locked their answers in? Pretty happy with where they are? Okay. So we've got here 2:3. Well, how much is that per bag? Well, that's $1.50. So which is the cheaper deal per bag? This one over here, 1 bag for $1.50. Over here was 1 bag for $1.67. That's about half and half the class on either side. So there's one thing that we can do, it's pretty close. Like if you were trying to do that in your head and you were in a supermarket and you didn't have a calculator, I mean, they're much the same. It's only 17 cents per bag difference. So it's probably not a big deal. So you probably wouldn't worry so much. And that's why it's 50-50, because if you don't have a calculator, you're just going to have to go, oh, they feel about the same. Absolutely fine. But if you did have the time to think about it a bit more clearly, or you had this idea about ratios, this is where ratios can be really helpful, because we can go, oh, well, on this side, each bag was $1.67. But on this side, 1 bag was only $1.50. So even though they're selling it as a 3 bags for $5 and it sounds like a good deal, not necessarily always is the best deal. Okay, so that's ratios. Okay, well, the key points there we're comparing the relationship between 2 quantities. The order mattered, the context mattered, and we had to keep the proportion the same. Well, rates are basically like ratios, except for we write them a slightly different way. And the key thing about a rate is that they have different units. We're comparing 2 different quantities. So unlike in ratios where we compare, say, chickens to chickens, or we can compare the number of red dots to the number of green dots, rate is where we have 2 different types of things happening. So in these examples, what I have are meters per second or kilometers per hour. So all speeds are rates. They're comparing the quantities, you know, how far over how length of time. This is another one. Say we're talking about maybe a tank has got a leak, and so it leaks out at some number of litres of water per day. Okay, so we've got measurements that are different units, and we can compare them. Okay, so there's a multiple choice question there available to you on your screen. Which of the following is not a rate? So we want to compare two quantities that have different units. So on the little pear deck down the bottom, there'll be a green answer button. You click that, the multiple choice options will come up. And you'll be able to choose which of the following that are there are not a rate. Yeah, I'm going to open up the responses. Try not to be swayed by what people have said here. Try and think about the responses, but I'm going to talk to them a little bit so you can change your mind if you want as we go. Okay, I said before that all speeds were rates. So the first one's a given. Speed is a rate. It's measured in meters per second. So that one is a rate. We're going to leave that one as that is. That one is. The growth of a child in centimetres over weeks. Centimetres, look a bit like this, centimetres per week. And so, yep, that one is a rate. That one's okay. Okay, the number of zucchinis picked off each vine. Sounds a bit weird, but actually we can write that as a weight. It would be zucchinis. Why did I pick such a tricky word? Per vine. So that would be okay. Maybe I can measure that as a rate of 3 per vine. Maybe I get 23 per vine, which is about what I had this year. So that one is actually a rate. That leaves us with this one. This is just a quantity, the number of television programs that I watch. I'm not comparing it to anything. There's no other quantity there. It's not ones that I liked. Over the course of 6 weeks, there's sort of nothing, no comparison there. So in fact, the correct answer is this one, because it's just a quantity, there's no comparison. Okay, well done. So we've talked through the ideas of rates. Now, a big part of this chapter of rates is being able to convert rates. And we might want to convert rates so that we can compare things, or we might want to convert rates so that we can see it as a different representation. So there's some very quick questions. Now on the pear deck there, you're just going to go answer and enter as a number. This should be super quick because this should be mostly revision. We just want to make sure we're pretty good at measuring in terms of lengths, and we're good at converting time. That will help us with our next activity. So very quickly, how many meters are in a kilometre? That should be super quick. How many meters are in a kilometre? Yeah, so we've got a lot of dots up here. Fantastic. Okay, next one. Conversions with measurements of time. So how many seconds in 5 minutes? So firstly, you'll need to know how many seconds are in 1 minute. Once you know that, how many are in 5 minutes? What do you reckon? Yeah, there we are, we've got it. So in 1 minute, there's 60. So in 5 minutes, there's 5 lots of that. 5 6s are 30, so there'd be 300. Fantastic. Okay, very one last one. If you can run 3 meters every second, how many seconds would it take you to run 600 meters? So again, keep the proportions the same. You can run 3 meters every second. So this is 3 meters every second. How many seconds is it going to take you to run 600 meters? How can I get, how many groups of the 3 meters do I need to get 600 meters in total? That's sort of what we're thinking about there. Oopsies, show responses. So how do I get from 3 to 600? I times it by 200. Yeah, so that's right. It's going to take me 200 seconds. Well done. Okay, so now we're going to look at some context. We've warmed our brains up. We're ready to go. The world record for a marathon is 42 kilometers long. It's a weird number. I don't exactly know why it's 42 kilometers. Maybe someone will know the answer to that. So there's a Kenyan who can run this marathon in 1 hour and 59 minutes. That's pretty fast. It feels like it's super fast to me. It takes me, half an hour to walk the 3Ks down to my local hall. So yeah, it's quite speed. So we're going to look at this and we're going to just do a little bit of things about rates with it. So we might want to ask ourselves, for example, what is the speed of the runner? Well, we could write speeds, as we've mentioned, in kilometers per hour or meters per second. It's normally a bit universal because we all get a feel for how fast those things are. So we could write the speed as 42 kilometers per 1 hour, 59 minutes. We can just write it like that. That's a rate. 42 kilometers per 1 hour and 59 minutes. But that's not very easy to visualize. You sort of don't get a feel for what is that? How fast is that? So we could do one simple thing. We could round that 1 hour, 59 minutes to 2 hours, very close. And then we could simplify it. So if you ran 42 kilometers in 2 hours, you could run 21 kilometers in 1 hour. So that's fairly reasonable. That gives us a bit of an idea about speed. We're used to speeds because it's a bit of a universal language. You imagine a car doing 20 Ks an hour. It's, fairly slow for a car, but it's certainly faster than what most people can sort of run. So that gives us a better indication about how fast this marathon runner runs. Okay, let's look at a very common application of rates, conversion. So we're going to convert this to meters per second. So the way I do this is I always spread it out so that there's where you're starting at the top and where you want to get to, your goal. So I've written the goal down here is meters per second. That's pretty important. What is the goal? So what's our first step? Well, how can I get, I'll have to change both the units, kilometers and the minutes. So what can I do? So the first thing I want to do is change the kilometers to meters. So how many meters would 42 kilometers be? At this point, it'd be great if you just threw some numbers into the chat. You can see that you're all sort of thinking and with me on this. 42 kilometers, how many meters would that be? So we know that there is 1,000 meters in every kilometer. Yeah, so there's some great answers coming through. Josephine's got it there, 42,000, that's fantastic. So yeah, 42,000 meters. So he can run 42,000 meters in 1 hour and 59 minutes. Well, that's great. We've at least converted the meters now. The other side, we want to get to seconds. So firstly, we need to know, well, how many minutes is 1 hour and 59 minutes? Yeah, fantastic, Chloe. So how many minutes in 1 hour and 59 minutes? So, well, in 2 hours, there'd be 120. So in 1 hour and 59 minutes, that's just 1 minute shy of that. There's 119. Okay, we're not there yet. Remember our goal at the bottom here is for meters per second. That's our goal. Okay, so let's convert now the minutes to seconds. How many seconds is 119 minutes? Now, at this point, we could do it, but maybe, what's our minutes? 119 minutes. How many seconds in every minute? 60 times 60. 7,140. That's what we want to have there. 7,140. Yeah, well done. Okay, so we're getting there. At least we've got the right units now. We've got meters and seconds, but we want per 1 second. So how do I get from 7,140 seconds to just 1 second? What do I need to divide by? Because then I need to do the same. Remember, it's the same as the ratio. Got a proportion up the same or proportion down the same. Okay, so we're going to proportion down. I'm going to divide both sides by 7,140. And we end up with about 5.88 meters per second. That's how fast the marathon runner runs. So wherever you're sitting now, see if you can visualize how far away 5.8 meters is. If you're in a bedroom or a study, or even a lounge room, it's probably not 5 or nearly 6 meters long. That's pretty big for a room. And they can do that every second for nearly 2 hours. That's pretty fast in my head. That feels like it's fast. Okay, just going to check the time. Yeah, okay, I'm going to finish this one off. So, 1,000 meter sprint. A 100 meter sprint, sorry. So we know that the world record for this is 9.58 seconds. Does anyone know who has that record? He's had it for a while now. Yeah, so Usain Bolt, well done. Yeah, he holds that record, 9.58 seconds to run 100 meters. What if I want to ask you how long to run 1 kilometer? How long will it take him to run 1 kilometer? Now, we're making some assumptions here. We're assuming he can keep up the pace for an extended period of time, which he probably couldn't, because that's like he's exerting a lot of energy in a short period of time. We're just going to keep that assumption. Okay, yeah, so we know that there's 1,000 meters in a kilometer, so we want to times that by 10. Yeah, so a lot of people threw that in the chat there. So 95.8 seconds. That's about 1 to run 1 kilometer. What do I compare to the marathon? The marathon is 42 kilometers. We know now that it's 1 kilometer. How long would it take him to run 42 kilometers? Well, you want to keep the proportions the same. So we're going from 1 kilometer to 42 kilometers. We want to multiply that by 42. So you do that on a calculator, probably. There's a lot of seconds. It's a bit tricky because there's a lot of seconds and I can't visualize that. So how do I go from seconds to minutes? Well, I would divide that by 60. There we go. It's about 67 minutes. So that's about twice as fast as the marathon runner. But again, he can't probably hold that up for 42 kilometers. It's a lot of energy. But just gives you a bit of an indication. He's about twice as fast. Okay, let's just do one of these questions and then we'll just jump to Q&A. Okay, so let's do this one. It's your turn. You're going to do 80 kilometers an hour to meters per second. I'm very happy for you to do this on the book in front of you. You'll do a similar process to what I've just done. Or you can jump to the next slide and you can do your working on the screen and throw your final answer in the yellow box. So you can work out on the screen or just work out on the paper in front of you and throw your answer up there on the screen. We want to convert 80 kilometers an hour to meters per second. Just going to give you a minute head start. And then I'm going to just start working through it on the screen. So if you don't want to see my working, if you want to have a go, then just tune out for a bit and do it, go ahead of me. But I feel like some people might like to see another example. So I'll use this as another worked example opportunity. So you want to convert 80 kilometers per hour to meters per second. So I'll just set that out how I would normally do it. I would start with 80 kilometers per hour at the top and I would put my goal at the bottom. That's just how I do it. It reminds me of where I'm heading, what I'm trying to convert to. Okay, I just want people to have a little think and get a bit further ahead. Okay, now, like I said, if you want to keep working on your own, that's fine. Tune out from my voice, but I'm going to work this through in case people want some help. I want to convert 80 kilometers per hour to meters per second. So where I'm going to start is with the time. I'm going to look at 80 kilometers per hour is the same as 80 kilometers per 60 minutes. All I've done is rewritten hours in a different way, remembering that I'm heading towards seconds. So now I know it's 80 kilometers for every 60 minutes. I wonder how many seconds that is. 80 kilometers for some number of seconds. So I know that there are 60 seconds in a minute and I want 60 minutes. So my calculator's a bit hidden under there. So let me just quickly get my 60 times 60. So I would know that 6 times 6 is 36. So I'm expecting this to have a 36 in it, and it does. So it's 3,600 seconds. Okay, so I've got at least the units right on this side. A seconds is good. I've got to get this kilometers down to meters now. So I know that there's 1,000 meters in every kilometer. So that's 80,000 meters. Okay, I'm doing there. I'm getting there. I've got the units right. Now I just need to get the 3,600 down to 1, because it's per 1 second. So the way I'm going to do that is divide both sides by 3,600. So I have to take my 80,000 and divide it by 3,600, because I have to proportion up or down by the same rate. I can't change the numbers. So when you do that on a calculator, you've got 80,000 divided by 3,600. 80,000 divided by 3,600 is 22.22. Okay, let's see how people went. Someone's taken some artistic license. Some people still working, that's fine. There's a couple of great answers. I can see some people have hit it. 22.22s there, and there, and there. That's fantastic. 22's close enough. That's fantastic. Meters per second, there's another 22.22. Well done. Well done, everyone. If you're still working on that or you've got a different answer, that's okay. Converting rates can be pretty tricky. It's okay to need to practice it a few times. My tips to you would be, where are you starting? What's your goal? Just do one step at a time. Just change one thing. And whatever you're changing, if you're changing it by a multiple, you keep the proportion same. Proportion up, proportion down in exactly the same way. Okay, there's another one on the slide. You can practice at another time. We're really out of time, unfortunately, but that's the idea. There's the key points out of today's lessons. Ratios and rates, about comparing quantities. Rates, basically special ratios, where we want to compare things that have different units. We treat them the same in terms of we need to proportion up or down the same amounts. The order is always important. The context is important. So if you keep those things in mind and you just work through one step at a time, each time you need to do a calculation, don't be afraid to do lines of working. It's really helpful, and it can keep you on track, because if you try and do too much at once, you can get a bit confused, especially with converting rates. So that's all we've got time for today. That's ratios and rates. As I mentioned, that's from our chapter 3. So this is from our Mathspace book. I'll just show you that. If you don't have access to Mathspace yet, your teacher can get it for you. That's fine. Just contact your teacher. Say you want to get access to Mathspace because you're doing these classes. And then within chapter 3 of the year 8, there's the ratios and rates that we've all just been talking about. There's some lessons there that talk a little bit about what we've been talking about today and hit those key points that I've discussed, and heaps of questions you can practice. Questions similar to the ones that I've just been doing, converting rates, answering questions about rates and ratios, and with the rates as well. The calculator I used today was GeoGebra. It's a very simple one. It's free and it's on the web, although most portable devices have a calculator tool. So that's kind of it for today, I'm afraid. The rest of that chapter had time. I just wanted to ask a question about that. Topics of time included 24-hour time and some things about converting, time zones. So if Perth is 3 hours behind us, what time is it in Perth right now? It would be 8 a.m., those sorts of things. So I didn't cover that today because, as you saw, we were pretty full just covering the ratios and rates. So this is I think it's our second last interactive question. is time something that you think would be important to come back to in the future, or you're pretty good with time? We could probably skip over it if you feel like you're on top of it, but if you'd really like us to cover it, let me know. So just go on, pick an option, yes or no. If you think you would like to see time or you're pretty good with it. If you do, I won't do it in the next 2 weeks because we're about to start algebra, but probably throw it in around when we were about to do measurement or something like that. Okay, so a couple of people there do want it, so that's the true. I'll let that keep going for a bit. So remember that it was yes or no, so true or false. Do you want me to cover time in the future? Things like comparing time zones. If it's 11 a.m. here, what time is it in New York? When can you call your grandmother who lives in Ireland? All those sorts of things. So just let me know if you'd like to see that in the future. Getting some more responses come in. Looks pretty overwhelmingly that it's good to come back to. Okay. That's fine. We can do that in the future. Okay. And now I've just checked the Q&A. It doesn't look like there's anything outstanding. Give me 1 second. No questions. That's fantastic. Okay, well, that's great. It was a good session, everybody. A little bit of time. Sorry about that. Maybe I should have had to do like the Pear Deck session. If maybe you could just throw that in the chat on your way out the door. Let me know how you like the interactivities that we did today. Do you want me to keep using those? Do you just want to use the chat like we did last week? But apart from that, we're all good to go. Remember, you can find the recordings. And yeah, I think that was a great session. I'd really like to be able to have your interactions and your responses. So next week, the first couple of sections in algebra. I'll just flip. Just look it up again. So we'll be doing adding and subtracting algebraic terms, multiplying and dividing terms, and simplifying expressions. So if you haven't done any of that in school yet, grab a book, find a book, have a little bit of a look through so it's not, you know, all new to you, and we'll cover it next week. That's it, everybody. Thanks for coming. When you close your Pear Deck down, just give it a thumbs up or a thumbs down if you liked it. Thanks, everybody, and I'll see you next week. Thanks. Bye, everybody.
Hi, everybody.